Alright, so we're starting our new unit. This is our last unit for calculus. Today is going to be trig functions, tomorrow as well. And we're going to start with sine and cosine functions. So let's look at sine and cosine functions. So here I have, here's a sine function right there. And I can turn on the cosine function. We all know what those look like. But what would the derivative of sine function be? If I turn that on, where is it? It's actually right with cosine. So the derivative of a sine function is cosine. So the derivative of sine x would be cosine x. Okay. Well, what about the derivative of cosine x? If I turn that on, it doesn't look like sine, does it? It doesn't quite match sine. However, if I put in negative sine x, it perfectly matches that. So the derivative of cosine is the negative of sine x. And I have these here. Okay? And we're also going to look at some other rules for how to take the derivative of, say, the sine of some function, if it's something other than just x, like 2x or x squared. Right, we're going to do some examples like those, but just briefly put, what you would do is first, you would take the derivative of sine, which is cosine, leave the function alone, but then you would multiply by that function's derivative. And as we go into trig and doing some trig stuff, these are things that are helpful to know. You've done these before in functions and advanced functions. Your special angles, right? Like what the cos of 30 degrees is, or the sine of 90 degrees. And also, not looking at degrees, but looking at radians. We're going to be using mostly radians, not degrees. Right? So for example, pi over 2, remembering that that's 90 degrees, right? Or pi is 180 degrees, and so on. Another good thing to remember, which you've done before, are some trig identities, because we all love trig identities. I love trig identities. Right, here's some good ones that are good to remember for this course. Right, we have our double angle formulas, right? And of course, the one I love these double angle formulas, compound angle formulas, and I didn't write it there, but cos squared plus sine squared equals 1. That's probably one that everybody remembers. All right, so let's try some examples then. Here's some examples we're going to start with. How do we find these derivatives? Okay, so let's start with A. So the cos of 3x. If we're going to find the derivative of that, so for A, first, the derivative of cos is negative sine. So we can write negative sine, leave the function alone, so 3x, and then multiply by the derivative of that 3x. So the derivative of 3x is 3. So the derivative of cos of 3x gives us minus 3. That was a terrible 3. There we go. Minus 3 times the sine of 3x. Okay, let's try B. So B, we have x times the sine of x. We have a product rule there. So remember our product rule. If we're going to find the derivative of that, first, find the derivative of x, which is 1, and then multiply by sine x. So we're going to start with sine x. Then we're going to add, leave x by itself, and then multiply by the derivative of sine x. And the derivative of sine x is cos x. Now, if you had something instead of x inside of that trig function, then you would multiply by its derivative. We technically do that here as well, but the derivative of x is just 1. So there's no need to multiply by 1. Right, so there you go. The derivative there is sine x plus x cos x. So our next two examples look slightly similar. This one says the sine of x squared. But in this case, if I put a little bracket here, this is what it means. The sine of brackets x squared. So to find the derivative of this one, first, the derivative of sine is cosine. So I'm going to have the cos of x squared. And then I'm going to have to multiply by the derivative of that function inside the brackets. So the derivative of x squared is 2x. So this derivative becomes 2x cos x squared. However, this is slightly different. This one I can rewrite to look like the sine of x and put that all under brackets squared. That's what the sine squared of x is. So we're going to solve this one kind of like a chain rule here. So the derivative of this one is first bring the 2 out in front. So we'll have 2 times that bracket, sine x, okay, reduce the exponent by 1. So 2 minus 1 is 1. And then multiply by the derivative of what's inside the bracket. So the derivative of sine x is cos x. Okay, so we get that this derivative is 2 sine x cos x. Which, if you want to write as the sine of 2x, if you remember some of your trig identities, that's fine. But you can just leave it like that. I'm alright with that. Alright, so example number 1 says to find the derivative of cos of 1 plus x cubed. So if that's what y is, dy by dx is going to be, well, let's first take the derivative of cosine. So that's negative sine of, leave this bracket the same, untouched. But then we're going to have to multiply by the derivative of this bracket. So derivative of 1 is just 0. And then x cubed becomes 3x squared. Okay, so we have minus 3x squared times the sine of 1 plus x cubed. So we're going to move on and do the second example. Now this one gets a little bit more detailed. So determine the equation of the tangent to the graph of y equals x cos 2x at x equals pi over 2. So you have to remember, see, we're using radians now. You're going to have to remember pi over 2 is 90 degrees. And you're going to have to remember some of your special angles. So if x equals pi over 2, we can figure out what that y coordinate is. So substitute pi over 2 into our function here. And you'd get cos of 2 times pi over 2, right? Which is just the cos of pi. Right? And the cos of pi is negative 1. This is just remembering your special angles. And so you have negative 1 times x, which is pi over 2. So you get negative pi over 2. So we have a point on the graph here. We have our x coordinate, pi over 2. And we have our y coordinate, negative pi over 2, which we got by just substituting pi over 2 into our function here. And we want to find the equation of the tangent at this point. Well, to figure out the equation of a line, we need a point and the slope. So to figure out the slope, we need to find the derivative of this function and then see what the value of that derivative is at this x coordinate, which we've done before in chapter 2, if you remember when we did derivatives. So let's do that. We'll find dy by dx. Okay, and we've got a product rule going on here. So first, derivative of x, which is 1, multiplied by the cos of 2x. So the cos of 2x. And then plus, now we're going to leave x and find the derivative of the cos of 2x, which is, well, the derivative of cos is minus sine of 2x. And then we'd have to take the derivative of that 2x in there, which is 2. So that leaves us with this function. Our derivative function is cos of 2x minus 2x sine of 2x. Now we're going to look at what that is at when x is pi over 2. So when x is pi over 2, dy by dx is going to be, so we have the cos of 2 times pi over 2, so the 2 cancels, so we just get the cos of pi, minus, again, 2 times x. If x is pi over 2, the 2's cancel, so we just get minus pi, times the sine of the same thing, pi. Now the cos of pi is -1, and the sine of pi is 0, so this whole term is going to be 0, and we're just left with -1. So that means the slope of the tangent at pi over 2 is -1. And because we have a point, we can write an equation. We're just going to use our slope equation. If you remember, it is m equals y minus y naught. So your rise over your run, which is x minus x naught. Where x naught and y naught is a point on the line, which is right here. This is going to be x naught, and this is our y naught, and this here is our slope m. So we get -1 equals y minus negative pi over 2, so double negative, so y plus pi over 2, all divided by x minus pi over 2. And if we just rearrange that, we'll get y plus pi over 2 equals negative x and plus pi over 2. So the pi over 2's are going to cancel, and we just get y equals -x. So there's the slope. So there's the equation of the tangent at that point. So the last example says determine the maximum and minimum values of this function, cos squared of x, on the interval where x is between 0 and 2 pi. All right, cos squared of x. That's the function. If you want to find max and minimum values or critical points, remember to find a critical point, you find the derivative and find where that derivative equals 0. So let's first start by finding the derivative of f of x. So the derivative then, so you have a cos squared, so remember you can kind of think of it like this. It would be the cos of x squared. So we're going to apply the chain rule here. So we're going to take that 2, bring it out in front. So we have 2 times by our bracket there, cos of x. Reduce the exponent by 1, so 2 minus 1 is 1. And then multiply by the derivative of what's inside the bracket. So the derivative of cos x is minus sine x. So our derivative of this function is then minus 2 cos x sine x. And if you want, you can write that as your identity, where 2 sine x cos x is the sine of 2x. That is fine. If you don't remember the identity, that's fine. You can still do the rest of the problem without switching it. You see, okay? So what we're going to do now is figure out when this equals 0. So when is this going to equal 0? And it's going to equal 0. This is where it is helpful to remember your special angles, or when x is 0. It's going to equal 0 when x is pi over 2. When x is pi. When x is 3 pi over 2. And when x is 2 pi. It's going to equal 0 at many, many other places, but remember, we're just looking at the interval between 0 and 2 pi. All right. So these are the areas where we are going to have a horizontal tangent, or a possible max or min. So let's figure out what those coordinates are. So I'm going to plug this back into the function. Okay, so if you plug 0 back into the cos squared x, you get 1. If you plug pi over 2 back into cos of x, you get 0. And of course, keep going, 1, 0, and 1. Right, so here we have some maximums at 0, pi, and 2 pi, and minimums at pi over 2 and 3 pi over 2. And we can, it doesn't say to sketch, but we can easily make a sketch of this. Right, so we're going from here to pi over 2 to pi to 3 pi over 2 to 2 pi. So it looks like this. There you go.